Welcome to our deep dive into the fascinating world of dinosaur extinction. While the asteroid impact theory is widely known, today we explore other compelling theories that might have contributed to the demise of these magnificent creatures. From the mighty Tyrannosaurus rex to the gentle giants like Brachiosaurus, these creatures thrived in diverse ecosystems. What could have caused such a dramatic extinction event, wiping out these dominant creatures from the face of the Earth? Join us as we delve into the heart of this prehistoric mystery. Our journey begins in the Deccan Plateau of what is now India, home to one of the largest volcanic features on Earth, the Deccan Traps. Imagine a landscape consumed by fire where molten rock erupts from fissures in the Earth's crust, spewing forth rivers of lava. These eruptions, which began millions of years before the extinction event, were colossal, releasing unimaginable quantities of molten rock, ash, and toxic gases. The Deccan Traps eruptions lasted for hundreds of thousands of years, periodically blanketing the Earth in a thick shroud of volcanic debris. Sulfur dioxide, released in vast quantities, reacted with water vapor in the atmosphere to form a dense haze of sulfuric acid aerosols. These aerosols, acting like tiny mirrors, reflected sunlight back into space, causing global temperatures to plummet. The Deccan Traps also released massive amounts of carbon dioxide, a potent greenhouse gas. The sheer volume released over such a long period disrupted the Earth's delicate climate balance, leading to extreme fluctuations in temperature and weather patterns. The once stable climate, to which dinosaurs had been so well adapted, became unpredictable and hostile. Plant life, the very foundation of the food chain, would have withered and died under the onslaught of volcanic winter and acid rain. Herbivorous dinosaurs, reliant on this vegetation, would have faced starvation, and the carnivores that preyed on them would have soon followed suit. The Deccan Traps offer a glimpse into a world in turmoil, struggling to cope with the devastating consequences of volcanic upheaval. While the asteroid impact may be the most well-known culprit, the Deccan Traps remind us that Earth's own geological processes can have a profound impact on life. As we delve deeper into the mystery of the dinosaurs' demise, we must consider the possibility that their extinction was not solely a result of a single catastrophic event, but rather a gradual decline brought about by a changing world. Imagine a world in a constant state of flux, where temperatures rise and fall, sea levels fluctuate, and continents drift apart. Over millions of years, the Earth's climate underwent significant changes. The once warm and humid conditions that characterized the Mesozoic era gradually gave way to a cooler, drier climate. These changes were not sudden but occurred over vast stretches of geological time. While the dinosaurs were a diverse and adaptable group, these long-term climate shifts would have presented significant challenges. As temperatures cooled, the lush vegetation that sustained many dinosaur species began to dwindle, replaced by hardier, less nutritious plants. Large dinosaurs, with their enormous appetites, would have struggled to find enough food to sustain themselves in a world where resources were becoming increasingly scarce. Sea level changes, another consequence of a shifting climate, also played a role in the dinosaurs' decline. As sea levels rose and fell, vast areas of coastal habitat were repeatedly submerged and exposed, disrupting established ecosystems. The fossil record tells a story of decline and fragmentation, as dinosaur populations became increasingly isolated and vulnerable to further environmental change. Our exploration of the dinosaur extinction takes us now to a realm often overlooked in the study of prehistory, the invisible world of disease. Imagine a silent killer, a microscopic enemy, sweeping through the dinosaur populations with devastating speed and efficiency. While fossils can reveal much about the physical world of the dinosaurs, they offer limited insight into the microscopic world of pathogens and diseases. However, we know from studying modern ecosystems that disease outbreaks can have a profound impact on animal populations, especially those already weakened by other stressors. In the late Cretaceous, as dinosaurs faced pressure from volcanic eruptions, climate change, and other environmental challenges, their immune systems may have been compromised, making them more susceptible to disease. Imagine a highly contagious virus similar to the avian flu spreading rapidly through dinosaur populations. Dinosaurs, being reptiles, were likely cold-blooded and reliant on external heat sources to regulate their body temperature. This could have made them more susceptible to viruses, which often thrive in cooler temperatures. A pandemic, sweeping across continents, could have decimated dinosaur populations, wiping out entire species in a matter of years or even decades. The fossil record, while incomplete, does show evidence of disease in dinosaurs, with some fossils exhibiting signs of bone infections and other ailments. While it is difficult to prove definitively the role of disease in the dinosaur extinction, it remains a compelling theory, a reminder that even the mightiest creatures can be brought low by an invisible enemy. Our journey through the extinction theories now takes us to the edges of continents, where land meets sea. Imagine a world where coastlines are constantly shifting, where once vast land masses are swallowed by rising oceans, and new lands emerge from the retreating waters. During the late Cretaceous period, sea levels fluctuated dramatically, driven by a complex interplay of geological and climatic factors. These fluctuations had a profound impact on the dinosaurs, particularly those that inhabited coastal regions and low-lying areas. As sea levels rose, coastlines were redrawn, inundating vast areas of land and transforming familiar habitats into shallow seas. Coastal plains, once teeming with life, were submerged, forcing dinosaurs to compete for dwindling land and resources. Imagine the impact on large herbivorous dinosaurs, like the sauropods. These giants, with their long necks and massive bodies, required vast quantities of food to sustain themselves. As their habitat shrank, competition for resources would have intensified, putting immense pressure on their populations. Conversely, falling sea levels exposed new land bridges, connecting previously isolated continents and allowing dinosaurs to migrate to new areas. The constant ebb and flow of the oceans created a dynamic and ever-changing world, one where dinosaurs were forced to adapt to shifting coastlines, shrinking habitats, and the arrival of new rivals. Our exploration of the dinosaur extinction takes us now to the very air we breathe, to the delicate balance of gases that sustains life on Earth. Imagine a world where the air itself is changing, where the levels of oxygen, vital for the survival of so many creatures, begin to fluctuate. The Earth's atmosphere has not always been constant. Over millions of years, the levels of oxygen in the atmosphere have varied significantly, influenced by a complex interplay of geological and biological processes. These fluctuations in oxygen levels had a profound impact on the evolution of life, including the dinosaurs. During the early Mesozoic era, oxygen levels were significantly lower than they are today. However, over millions of years, oxygen levels gradually rose, reaching a peak during the late Jurassic and early Cretaceous periods. This increase in oxygen is thought to have played a role in the evolution of giant dinosaurs, as it allowed them to fuel their massive bodies and active lifestyles. However, towards the end of the Cretaceous period, oxygen levels began to decline. Large dinosaurs with their high metabolic rates would have been particularly vulnerable to these changes. The changing atmosphere, once a key factor in their success, may have ultimately contributed to their demise. As we've journeyed through various theories surrounding the extinction of the dinosaurs, one thing becomes clear: the answer likely lies not in a single catastrophic event, but in a complex interplay of multiple factors. Imagine a perfect storm brewing, a convergence of environmental pressures that pushed the dinosaurs to their breaking point. The asteroid impact, with its immediate and devastating consequences, undoubtedly played a significant role in the extinction event. However, it is highly likely that the dinosaurs were already facing a multitude of challenges before the asteroid struck. The Deccan Traps eruptions, spewing forth toxic gases and blanketing the Earth in volcanic ash, would have weakened ecosystems, disrupted food chains, and left many dinosaur populations vulnerable. Climate change, with its long-term shifts in temperature and precipitation, would have further stressed these already struggling populations. Sea level changes, shrinking habitats, and the potential for widespread disease outbreaks would have added to the pressure, creating a world in which dinosaurs were fighting for survival on multiple fronts. The decline in atmospheric oxygen levels, robbing them of the very air they needed to thrive, would have dealt yet another blow. Imagine the dinosaurs, once rulers of their world, facing this relentless onslaught of environmental challenges. Their numbers dwindling, their habitats shrinking, their bodies weakened by a changing climate and a thinner atmosphere, they were pushed to the brink. Then, the asteroid struck, delivering the final blow to an already fragile ecosystem. While the asteroid impact remains the most accepted theory, it's clear that multiple factors likely played a role in the extinction of the dinosaurs. From volcanic eruptions to climate change, the true cause is a complex puzzle. By studying the past, we gain valuable insights into the present and future of life on Earth. Thank you for joining us on this journey to uncover the mysteries of the past.